Good job.
Oh, thank you for the offer very much. Thank you.
I can just pass it down. People there, don't worry, I'll take care of it.
So okay, we have a break.
Also, we have a party. Yeah, that's right.
We have a pineapple party.
So I'll take one box. Don't take any of us. Okay.
Okay, guys. We ready for the next one?
See you guys tomorrow.
Ready? Yes.
So we have next one. So Clark, he's gonna present about software documentation and architectural analysis of full stack development, which is he's gonna provide analysis on how to increase the level of engagement to open source full stack development. So using 3 C's, the first one is comprehension, and the second one is communication, and the last one is collaboration. So these three gonna help increasing engagement to full stack development. Please welcome Clark.
Thank you. Hello everyone. I know it's not yet my capstone quarter, but here we go. It's abstract time, and let's start with the title. It's called software documentation, meaning details about the software on how it works, the version number, and what are the other components, the dependencies, who's using it, basically why are we using it, when are we going to use it, those stuff you can see in documentation. And architectural analysis basically gives that software a high level overview. Instead of like going through text all the time, you would have diagrams to show how each component interacts. And again, the target for this is full stack development because of Apprenti. Hooray. So without further ado, let's go to the outline, basic outline of a capstone. We have problem statement, motivation, previous source, onto references. And moving along, the problem statement is open source software is very complex. It has a steep learning curve to be able to use it. The document is also inadequate and does not show the big picture due to the complexity. So it means that, yes, open source software is a really great innovation in our time. Like anyone can join. You can join. You can join. Others can join. Sure. But now, question is, how do I join? Well, just create a GitHub account, but not really, because now, how do I contribute to the source code? You check the documentation. It just says, okay, what it is for, how you're going to use it, for what, and then, but what about the code base? Who's explaining it? So now it becomes hard to understand the code base first, and then now you're in the, you're going to have a hard time to contribute to the code just because you need to learn all of the code base, which is, again, difficult. So documentation is inadequate, and it does not show the big picture. Hence, that's why we want to use the architectural analysis to give, hopefully, the whatever open source software, or we can also do it internally with our hands-on practices, that we give a big overview, diagrams. So students immediately seeing that, I know what are we going to do. Next, for the motivation, again, what I told you guys earlier, it invites everyone, but again, the technical capability to do so, it's hard. And that's a big barrier to entry. Another motivation is full stack development is difficult to learn. See, silence, yes. So as for the reference, the first one is basically a reference to a study by William Kim, and advisor is also Sam. Basically, they reverse engineered a software, and they try to analyze how easy it is to contribute to open source or not. And next is full stack web development. Basically, there's another journal that I saw. It's Node.js challenges and implementation in 2017. So I'll be showing more images for this current literature review from the second source. But before that, I'll give you an example. So if you go to GitHub and you go to Node.js, you'll see this. A description, an outline, and basically you would have a lot of details, but no diagrams, no architectural analysis, nothing explaining the code. Okay? you would go to documentation, sure, it explains per API how you're going to use it, but again, how does this work in the big picture? Another example is mean stack. And it's not being even maintained correctly just by seeing on the top, like dependency, referring coverage, even they have a broken image here. So there's no maintenance. And again, as you can see, even when it was popular, they don't even show you how the text line up to each other, right? And then how each one works. And I mean, it describes how each one works, but there's no architectural analysis for that one. So going back, what I told you earlier, the second source I was using for a literature review, basically what they did a qualitative study, and they interviewed a lot of developers about, in this case, Node.js. So as you can see in the first picture, how much do you know Node.js? And basically think of red as no, and going towards green is yes. And you can see is a lot of them do know Node.js. I mean, aware only, okay? Next is learning of JavaScript for Node.js was a challenge. To some extent, no. So it's still kind of easy. But as we look in further, next is, now again, if you want to learn Node.js, we have to learn all the fundamental programming concepts like for loops, if statement, conditional. But aside from that, we also need to learn asynchronous programming, like the timeout, promises, callbacks, which is a feature of Node.js. So now they're talking about a feature of Node.js. Now you can see the red part is so much bigger. It's harder for them to understand even the concept. Even the non-blocking I/O, it's bigger. And last one, the asynchronous processing feature, again, it's a bigger red. So again, the motivation is with architectural analysis and more documentation. I hope this decreases more, okay? Next is for the previous work. This is from the first reference. Basically what William Kim and Sam did was they had this Sparks Enterprise Architectural Modeler. And what it does is basically you can plug in your, I think this is Java code, and then you can generate your architectural model. So we'll try to simulate something like that. We don't really have, we can generate the code base, the code files, but let's see if we can generate the same thing. My approach first, I want to talk about this concept again of the zone of proximal development. So a lot of us, when we started learning how to code, things you can do all on your own. An example of that, you can study if statements on your own. You can study conditionals on your own. But now you go to here, things you can do with a bit of help. Let's say promises, callbacks. So you would ask someone, and it speeds up your learning, okay? But if, let's say, you're doing if statements, conditional for loop, and let's say, oh, can you check the code base of Node.js? Now you're here. Things you can't do no matter how much support we get. So our aim is actually just to move the person towards the middle so that now he gets comfortable and becomes the things I can do by myself. And now the, let's say, contributing to Node.js source code becomes the things you can do with a bit of help. Okay, so again, this is how we should teach people that we should not try to push them over this right away. So again, the sample would be hopefully creating an architecture first, describing what it is it the backend server, is it how it's going to interact with the client, how it's going to show to the client, how are requests being done. So we're just going to show these images and more details, hopefully. And next is show them design of how they interact. So even in the mean stack, open source repository, they don't even have this very wonderful image that it shows that, hey, client server and backend server are separate things. It doesn't mean it's a stack, it's all in one code base. No, we separate them. And again, what's nice with this diagram is it also shows the architect, like, oh, it's a backend server. And now what is the backend server? You have Node.js, and Node.js and Express is being used as a framework. So on and so forth. So hopefully this, again, will give them more idea before they deep dive. So for implementation, again, we wanna use this. We wanna make this research useful. So one of the immediate target, we are gonna dog feed this. When we say dog feed, you do something and you try to consume it on your own if it's good or not. So you try to create documentation and software architecture for our hands-on practice 1 to 10. And let's say for hands-on practice 1, we just show Node.js and show what it is all about and deeper on Node.js. And then keep that same picture, go to hands-on practice 2, and expand that picture, go to hands-on practice 3, expand that picture a bit more. So we'll try to do that. And then if we have more time, we can create a video walkthrough as well. Again, you can put this in your repository. It will really, really be helpful for people. And then we can also grab a best practice of documentation from a known company like Google or Apple, whatever. So for the tools, basically we're gonna use VS Code for our text editor, GitHub for repository. Tech stack is Mean Full Stack, which includes MongoDB, Express.js, Angular, TypeScript, and Node.js. For architectural modeler, we're going to use the Spark X Enterprise Architect, expensive application. Video, we'll try to just upload it in YouTube channel. And theory is the 5W1H redoc. It's a reverse engineering process that was derived from the 4+1 views. But this 5W1H basically means that who, when, who, what, why, when, and then where, and then the H is how. So again, if you talk, again, just going back, architecture is it's like the overview, and then design is like how you're gonna implement it. Okay, I think this one was created in the paper by William Kim and Sam Chung, this 5W1H. And the demo, we're not gonna do extra work, so we're gonna use the Bookstore web app to do that. For the design, we're gonna use the Unified Modeling Language. Stick with TypeScript and MinStack, that's why we can do TypeScript, JavaScript. DB translation, object document mapper, just because we're using a MongoDB, which is again a document object database. And again, if you don't know, ORM and ODM, ORM is for SQL databases, ODM are for NoSQL databases. So basically, instead of doing a direct query inside of your application, you can just have the languages their own way of writing so that you can use the objects in your JavaScript and now translate that to SQL or NoSQL queries. Experiment, so again, will be like a video walkthrough. And the other one is putting a diagram. As simple as that, like giving them a process of how the flow of, like, let's say you create a server, HTTP request, and how it interacts, okay? Next is evaluation. It's gonna be a qualitative study, again, a survey, and we would ask questions like, do you think this is effective for you? Do you think that you comprehend more? Because again, we're going back to what we really need for open source contribution is to have collaboration, communication, collaboration, and what's the other one? Can someone remind me? Communication, collaboration, comprehension. So yeah, so this flow is a sequential flow. We need comprehension first. If we help the student or developer comprehend, then now they would have more knowledge on how to communicate with other developers. Once you've done that, now you can collaborate to the source code. Okay. For the references, right now I just have 3. We're gonna study up more, and that's it for now. So please ask me questions so I can improve and finish Capstone very fast. Okay, thank you. Question?
Is it a tool Spark X?
Yes.
Is it like, can you use the tool to create the UML?
Yes. And then again, it's expensive, so Sam is sponsoring it. Yeah. Expensive. So this tool, again, if you have a code base, it basically, I think at the click of the button, you would generate this. If you remember in one of our classes with him, is we executed the code, and we get this deployment view, process view, design view, use case view, and again, different views are for different persons, like end users. You can give it for a system architect. You can give them to a developer, and business analyst. Depending on your role, you would check different views. Powerful tool, expensive tool. More questions?
Does it generate like code by doing backward?
I
Yes.
think yes. That's why it's very expensive.
But they cannot implement algorithm. Because of that, usually good companies, they have this kind of a title, software architect, usually very senior level. If you can find that title, that company code is very stable. Looks like, United States, we have an interstate highway. At least the top level, somebody must know how they are connected, right? Also how they want to design it. This is the Carnegie Mellon University Software Engineering Institute. They really emphasize this one. If you need more, talk to the Amaru's husband.
Amruta,
I think
yeah.
He got the master's degree from Carnegie Mellon University. So if you talk to him, he
Carnegie Mellon, yeah.
And then also, this one, if you are using object-oriented language, especially mobile phone application, if you do not use the obfuscation, means you hide them, mix them, otherwise they got the APK file right away. They can within second, hacker can create the whole source code architecture.
Yeah, because
That's
again,
why reverse engineering, software reverse engineering, they are using this kind of tools.
so just to add, just because again, some attackers just leave their servers and have web crawling running and looking for API keys.
Yeah.
But again, don't worry as much as well, because even GitHub and AWS has their own crawler that they know that, oh, okay, your API is exposed. You have to change or we'll delete your account. Yeah.
I got that notification a lot.
Yeah.
Okay, so the Williams paper, if you search, that was published.
Yes.
Current one is a master capstone report. If you search that title, you can see the ACM,
Okay.
RIIT, I didn't publish. Okay. Go back to the one you first slide, problem statement. Problem statement, you should have question statement.
Yep.
Not explanation.
Okay,
This
thank
is
you.
somewhat close to the motivation. Then you have to solve what problem are you solving? The problem statement in
Question mark.
statement. Yeah, question mark.
Okay,
That's
thank you.
very strong. Okay.
And you said a custom statement?
Question mark.
Question mark.
Because like it's kind of done. It's problem statement, but it's curious.
So how can I reduce the, okay, this one, you can make this one. How can I reduce a steep learning curve to the
Yeah.
end user? Like that statement put up right away.
Yeah.
Yeah. Otherwise, this problem statement is not clear, and it will be delayed everything.
Okay.
Also, what is the very good problem statement? Somebody, some paper, after conclusion in future work, somebody mentioned that you have better solve this problem. If we have a reference, this problem statement is very strong. Yeah.
Okay. Any more questions? Okay.
Thank you.
Thank you again.